Say, Satan, get behind me.
George and I wait next to the door like this with the smart board. He walks in, wham! Break his face. Simple.
Alright, cool kids. We have a similar example to come and hopefully got the old one down. We're going to try and practice this one as much as possible. We might end up going into tomorrow a little bit as well, so we'll see.
What is like
Hi, Joyce.
17?
Ooh. Did you notice I drew a 7 on the page before?
Yes.
It's more like an arrow.
You were there, wasn't you?
Yeah, you did. Okay.
You'll see it. Technically, integration by parts is just a formula which comes from the product rule, which is the one that we saw, we kind of, in a sense, found yesterday. Technically, integration by parts is just a formula. A silly way of remembering it is called Lucky 7. There is a part of integration by parts, an application that has to do with a table, and that one's called tic-tac-toe from Stan's delivery last year. But Lucky 7 is just my way of remembering.
Well.
And remember, what's the point of integration by parts? You have two arguments, two pieces inside an integral, somewhat or maybe entirely unrelated, that do not seem to be able to be related by any of the other methods that we've used so far. No partial fractions, no trig identities will help, no integration on crack will even help. Okay? Now, hold on. Are you going to know whether or not it's an integration by parts problem to begin with?
No.
Probably not. So if you're not going to know, what are you going to do? Probably try USUP. Probably try some sort of integration on crack. Probably try something funny. But hopefully after a lot of practice, we'll get used to seeing which ones you should just go straight here. And so far, you've already seen, because this example looks a lot like the other one. If you have a trig of an argument whose u prime or du does not match the outside, I'm guessing it's going to be integration by parts. Okay? So we're able to look at an integral and in essence deal with two separate pieces. A u of one function and a dv of another.
Is it going to be an endeavor out of curiosity?
Yes. Oh, that means I have to do this.
You only have one there.
Yeah. My list right now is all deadlines for right now. Holy piece for that.
Why can't they be live lines? Why is everything got to be dead?
Got a budget.
Yeah. Joyce, if you agree with me, leave a comment in the description below.
Or don't.
Come back. Come back. All right, so what have we seen so far? The u, right? The u goes to a du. Why am I saying goes to? Because the idea is by using integration by parts, we get an integral that is more solvable. More easily solved, more able to be solved. Or at least closer, one step closer to one that could be solved. So, if a u becomes a du, in essence, not becomes like it doesn't like magically poof, it gets plugged into the formula. But if an integral with a u becomes an integral with a du, then we probably want to choose u to be someone who is easily derived, and more specifically, who derives to be someone simpler. We probably want to choose the u as a piece that derives to be simpler. Now, just a quick heads up, that is not always possible. It's not always possible to choose a u that derives to be simpler. But frequently, those are the easiest, the most basic, the most straightforward types of integration by parts problems. The u, you want to choose to be a part that derives to be simpler, and then the dv, basically. You choose the dv based on something that can be integrated. Why? Why is that crucial?
Because it's pointless.
Yeah. If dv cannot be integrated, how on earth am I going to get v? If I can't get v, then I can't do integration by parts. So you're considering two different things when you're trying to do integration by parts. When you look at an integral, you're trying to choose a u and choose a dv. And just a hint, the dv always has the dx. Why? Because he's a derivative. He's going to have the dx as a part. The dv is always going to have a dx. The dx, he's going to take them along with him, and then the u derives to be simpler. So looking at this problem down below, this is endeavor number, I have no idea, so we'll figure it out when I update my endeavor. Sound good?
Sounds great.
But he is important. He has easy memories. Sorry guys, you're getting in first year of a new book is always a little rough. Okay. Who do you think you should be? Well, who are my two pieces? X and sine of 3x. And the dx, he just goes along with dv, whoever we choose him to be. Why not choose u equals sine of 3x?
Too complicated.
It's not too complicated. I did the derivative of it.
Doesn't make it simpler.
It doesn't make it any simpler. And if I were to choose x dx as my dv, the integral would be x squared over 2. It just got harder. So instead of choosing u to be sine of 3x, we're going to choose u to be x. We're going to choose sine 3x dx to be dv. And here's how I orient it, and this is why it's called Lucky 7. I write the u first. Who do I choose to be u? X. V I don't know quite yet. dv or du I don't know until I solve for it, but dv I do. Now, this is not as every math teacher does it. Everyone has kind of their own way of teaching integration by parts. Some of them do it u and then dv. But for a simple one, I just go for this one. Now, Lucky 7, in order to do it, we have to fill in all the pieces. So, how do we go from u to du? Take a derivative, and it should be 1 dx. What? Oh, du dx, move the dx to the other side. I'm going to plug it into an integral soon, so I want the dx separated. What do I do over here? That's derived, and this is going to be integrate. Think going backwards, right?
Ooh.
U is equal to 3x. Hopefully we can maybe get this in our mind. Du would be 3 dx. I divide by the 3. Are you going to have negative 1/3 cosine 3x? Are we okay?
What? How'd you get the 1/3?
Because the u prime x is on the inside.
I'm going to have a u prime of 3. I need it to cancel out. Kind of like power law. When you increase the power, you have to divide by it so it cancels. So I can show it.
Because if you do u sub,
Technically for dv, you can always do a little integral if you need to, right?
Make u 3x and then.
Do it separately. Just use it. Yeah.
And then you have to pull out the 1/3.
oh,
And then the integral side of u is negative cosine of u. And it's just 3x.
That makes sense. And then why no plus c? Technically there is a plus c, except
We're not done.
we're not done. Good. And where is the d going? Back into an integral, and we're going to have a plus c from that. So we could always put plus c, but there's really no point.
Plus c and then plus e and then plus 3.
Now, why did I say lucky 7?
And you gotta draw a lucky sign.
Why? uv
And then d
minus vd.
will be
It's just a way of remembering. It's just a way of remembering. uv minus vdu. Just memorize the formula. That's what a lot of college classes would do, and they just have you write it however. Probably with u and then dv. U derives down, dv integrates down.
I don't think that 7 is really lucky. You have to draw another one.
Oh, and this one.
I think so. It's gotta be lucky.
And this one.
Gotta get
This
3
one we're going to be done. Because then we can go ahead and do u times v. It's going to be negative 1/3 x cosine of 3x minus v du, but minus and negative will be a positive, minus the integral of v du. I can pull the 1/3 out. I just have cosine of 3x dx. I don't need another integration by parts.
Wait, we integrated twice though.
Oh, we do integrate twice. You always have to do it with lucky 7.
You integrate the same thing.
But sometimes you have to do integration by parts twice. I thought that's what you meant. So in our answer, we did an integral. What was the point? This is dumb. We still have to integrate, but it's possible, right? As opposed to impossible.
But I'm just confused on, isn't
The formula says you take,
right?
you find u dv, identify your parts, and then fill in the formula. So u times v minus v times du. Now that x is gone and I have somebody I can finish. So I'm going to finish by, u is going to be 3x again, so du I need another 1/3. And it comes from the sine of 3x plus
Wouldn't
c.
that make that part like f double prime and then we integrate it twice to make it f?
Yeah, but we didn't integrate the same thing twice. So this is just a strategy for how to basically break this apart and break it down and kind of do like a product rule-ish sort of thing with integration. Does that kind of make sense?
is a genius.
smart. So then I guess, I don't know, the only thing I can see is pull out a 1/3, but it seems kind of silly because there's a plus C anyway, so I would just go ahead and write it as,
How come the du goes away? The u goes away?
actually I feel like they pull out a 1/9. What was that?
Why does the u go away from x?
U was X to begin with, right?
No, because it's integral v du, but you have a dx.
Because I plugged in D, 1 dx. Same way I plugged in D, I plugged in D.
And what's, that's equal to the integral of u dv?
Uh-huh.
And so we have to set that equal to it, or we have to?
Well, technically, who is this equal to?
Um,
The integral of x sine 3 x d
no.
x. Dun, 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 dun. And actually, George, this is really important and soon. So I'm actually glad you said something about it.
But, okay, so u, does that represent?
So
When
this
you put
is,
the integral of u dv, are you saying u is the whole argument, or just the part
no,
that made the
u is the part that you make it. And dv is the part that you make it. So
Oh,
I
right,
made
right,
this. Does that make sense?
Oh, yeah,
So it's like u dv dx.
So it's u and dv and dx goes with, because you need that as your dv dx. And the whole point is, once again, you have two pieces and you can't resolve them with normal u sub, so there has to be another way of breaking it apart, and integration by parts is that way. Oh, sorry, that was the one we just did. So, from what we just did, who do you think you would be?
Oh.
Hold on, guys.
They're both?
Try it. Let's see what happens. Sometimes experimentation is the best way to explore. If you're thinking, yeah, like dv is ln of x, you can. How do you integrate ln of x? So just x then.
How do you integrate?
Exactly. That's what we're doing.
Oh, that is what we're doing?
So dv is 1. Yep. But 1 dx. There is a formula the book gives for integral of ln of x, but I don't like it because I think it's dumb because there's a way to do it with integration by parts. But do you guys see why I'm doing normal use of? Because if u is ln of x, I need a 1 over x now. Got him. In order to get him, I have to do an e to the. I don't want to do that. But what's left over if I used everybody right there?
It's 2 ln of x over x.
That's all I got left over there. So in the du, Roger just started going 2 ln of x times 1 over x dx, right? Bring down the 2, make it a 1. You heard. Who's v going to be? So you have to be good at integrating, right? No plus c because it's not going to matter eventually anyway. Driving down, integrating up.
So you should start with trying to find out what you should integrate first.
What can be integrated maybe. But remember I said 2 different ways. Either who becomes simple with deriving or who can be integrating. You have to kind of bring those two together and think about them both in tandem. Minus, right? UV minus. The integral of b du. Wait a minute, what happens when you multiply b du? The x is canceled, you just have an ln of x dx.
Well, we can, you know.
Exactly.
Do we have to do it again?
Yep.
What a savage.
Why is
So
it
who is your uv?
U would be x. No, u would be ln of x.
Why are we doing that? Because we want to break down the ln. We can't derive him. No, we can't integrate him. So we can't put ln on the dv side. We're breaking it down. But don't you notice as we're taking derivatives what's happening to the ln?
Deteriorating.
He's disappearing. Yeah, he's
So how do we get-
deteriorating.
How do we get one dx again?
Oh, it's just what's left. Just the x, so you can think of one. Yeah. So we have to go back to d. That'd be an x again, right?
Let's do.
Let's just.
Welcome.
So we end up with the integral of ln of x squared dx is equal to x ln of x squared minus 2 times right? That integral becomes uv minus v du for the next one. If you want to do subscripts, sure, but you don't really need to.
Why does 2 come out?
He doesn't come out, he's already there. Remember, this is just for solving this little. Because there's 2 right there.
Constant multiple rule.
uv minus v du. 2 is a constant. Remember, we can always hold a constant. I'm just solving this integral with integration by parts. I've written everything up to the 2, and now it's time to say, hey, who are you? Oh, that's right, uv minus v du. The x's cancel, it's just a dx. I can do that one. I'm rewriting, right?
How did you get ln of 2d, ln of x to equal v and v equals x?
Oh, that doesn't equal v equals u. Oh, that doesn't equal v x does.
Yeah, but if it's integral of v du,
The x's cancel, dx stays, 2 ln of x goes in, the 2 is a constant. All of this, right?
Yeah.
uv minus the integral of v du. These get multiplied, put into an integral. uv minus v du in an integral.
Oh.
So then I just saw x times 1 over x cancel, right? ln of x dx stayed, 2 is a constant.
So plug in for v, plug in for du.
Right, plug into the formula. uv minus the integral of v du. Right, that's what we're doing every time we do like this. We're plugging into that, the foundational formula. This is so fun.
How would you take that flow, or is that just?
Oh, hold on, it's coming, hold on. So we have equals x ln of x squared. Basically, tic-tac-toe is built upon what if you have something that needs repeated integration by parts and maybe even more than just 2.
Minus x.
Ah, ah,
Oh, 2x.
Minus 2x.
ah!
Plus 2x.
Woo! Oh man, you have to write an extra step or else you're gonna mess it up.
Alright, and then we can plug an x ln of x.
behind you.
Right? What's the integral of 1 dx? X, and then distribute your negative 2. Negative 2 times negative x is positive 2x plus c.
Can't you do ln of x to 2x?
Simplification.
Oh, x to 2x. I guess if you want to. But you're right, Jordan, you can't. I just don't know if you need to. But that's just making it match. That's just pretty awesome. Alright, we okay? But do we see how little mistakes can happen? Okay.
So don't do what I did.
So guidelines.
The integral of dx is just x, right?
The integral one. Now, there are many different approaches to integration by parts. This is just one person's general idea. It's actually the book from last year and a conference I went to, their idea, Viate. It doesn't always work, but this is the general approach. We've already talked about let dv be the most complicated part that can be integrated, right? I mean, I kind of already summarized it, so you can see if you want to write anything else down. But you try to let dv be the most complicated part that can still be integrated. Like the last one, ln of x can't be integrated, so we didn't put that in the integral. Try letting u be the portion of the integrand whose derivative is a function simpler than u. So we're trying to choose u that derives to be simpler, while choosing dv who can be integrated. Now, which one do we have no option on? Those are our two desires. U derives to be simpler and dv integrates. But which one is crucial? Which one is required in order to be able to do integration by parts?
DV, right?
Yes. If dv can't be integrated, then I am not able to finish, right? So even though I want you to be someone whose derivative is simpler, I have to choose the dv that is someone that can be integrated. So anyway, both of those work together. This also actually states the note that dv always includes the dx of the original integrand. But then underneath this little just general guidelines, and this is a good one. I kind of summarized it, but I also said some things and we didn't write them down, so I figured, let's go ahead and get this little box in. There is another quick hint for how to choose u for integration by parts, right? For integration by parts, not use it. Liate. If there's a logarithm, almost always, you've tried u sub or you've looked to see if u sub works. If there's a logarithm, u sub doesn't work, normal u sub, that logarithm almost always has to be u. Because we cannot integrate a log unless we memorize some nasty formula or just do integration by parts, choosing u to be the log, the ln, the whoever. So this is how you choose u. If there's a log, choose it. If there's not a log, but there's inverse trig, choose that. If there's not a log, not inverse trig, but there's something algebraic,
With what?
like square root of x squared plus 4,
Okay.
something like that. Some algebraic. So basically something without logs or inverse or trig or exponentials. So then choose an algebraic if you can. If there's nothing algebraic, choose a trig. If there's nothing trig, choose an exponential.
If it's none of that, then probably gonna solve nothing.
Right. Or,
Well, I mean, it has to be one.
Or it's really crazy.
well,
Or
what
as a
else
whole.
is there? Yeah, right? But George and I are like, well, if it doesn't have any trig or any exponential or any logarithms or anything algebraic or anything,
And it's pretty much a constant.
yeah, it's a number.
And you don't need the integration. You just need mathematics.
Well, something like
For a logarithmic one, logarithmic.
logarithmic, yeah.
Yeah. Could you do like change your base and then do change your base would be the ln of the top minus the ln of the bottom, and you integrate separately?
So if could you, yeah, theoretically, but if you do change your base and if you just had a constant, it would just come out anyway, you'd still have another log. Remember, change your base, you still have a log. Does that make sense?
Yeah.
But yeah, you can always change the base and not have to think about the log base being u or whatever. So liate.
Oh, it's the
Well, you can put the accent. It's not really a word, it's just a way of remembering, so.
You could go tail. with
Liate.
the, No, yeah.
Liate, liate.
It's demanding.
How else can you say it? I don't even know. We're done.
Oh,
Who's you?
me.
You got negative 4x. No, that's
Who's you?
TV.
Me.
Is there a log? No. Is there inverse trig? No. Is there something algebraic? Yes.
Oh, so just negative 4?
X. Right? We have to get ourselves out of the u sub phase.
Okay.
But wait a minute. Is it bad? Because this is just a section of entirely integration by parts examples. But wait. When you see this on a test, you're going to try u equals negative 4x, right? So why doesn't it work? What's u prime?
Negative 4.
Negative 4, there's an extra x. Oh, solve for, nope, that would get an ln in.
Yeah, I'm never getting that one.
Don't do that. Right? But what if this was negative 4x squared?
Yeah.
Oh, u sub, right? That's all you need. Okay. But, since it's not negative 4x squared, it's just negative 4x. Who's u? X. Why? Who's du? Exactly, and he's what's going in the new integral instead of the x that was there causing all the problems. dv is, and as I go back, who's v?
Negative 4 positive? Negative.
Careful. You can always double check, right?
Right.
E to v times u prime negative 4 and then it cancels. Then our the integral of x e to the negative 4x dx is equal to,
Can I go to Vegas with these lucky sevens?
huh?
Can I go to Vegas with the lucky sevens?
I'm sure it's going to help you much better.
Yeah.
You can. You get minus the negative 1/4, which became a positive. We're not killing any poor seals by messing up our negatives.
Seals. I like seals.
Are we good? Are we golden? Are we ready to solve?
It's integral of v, which is negative
So like U bounds for integration by parts? No.
You just have to get back to x's and do it that way. Because what do you do the infinite? No.
Yeah.
Because you change references somewhere. Okay, those real quick, just because the AP guys, I see two negatives. I'm not saying they will necessarily, but if I were trying to be like them, I would pull out a negative 16. No, a negative 116. Why? Why would they do that? Why not pull out the negative 1/4?
Because
Before
16 is smaller.
Yeah. And it gets rid of both denominators, because if you pull out 1/16 from 1/4, yeah, George, you're going for it. 4x e to the negative 4x, right?
Yeah, plus e to the negative 4. Then you can pull out e to the negative 4. Oh, no, you can't. Oh, but then you have.
You
Oh,
technically
the C
could.
is fine.
I was just trying to show you the concept, but yeah, you could.
The C is fine. Because
The C is fine because it's going to be, the C could be on the inside or the outside. On the inside, you have to be,
C over 16.
yeah, and on the
Which would be
outside.
another C.
Which would just be another C. So
Hence why I pulled it out.
if we pull out e to the negative 4, it would be C over e.
You could still do that. I feel like they would still be, right?
You know, it's funny you call it witchery, George. My sister calls all calculus witchery.
Right? It doesn't look like a nicer answer. I kind of think
I
it does.
just, but are we allowed to pull it out because of the C though? Because you have the C over negative 4? Or are you allowed to put it outside?
Well, this can be anything.
Well, now technically, the C is separated already. Does that make sense? So since it's separated already, then the e to the negative 4x pulled out.
That really does look like a nicer answer.
Doesn't it? And that's why they do it, because they want a nice little linear factor, especially if you're doing like critical numbers or zeros or something.
Oh, why would they give us that? Why would they give us, like,
Because of the
He's just saying hypothetical.
Saying hypothetically, they'd like in general to pull out the nastiest fraction in order to have only whole numbers on the inside for circumstances like separate from ones where you would do that factoring that doesn't have integration by parts, and then you would find the zeros much easier.
this is gonna need multiple U's in there.
D is 1
I don't know.
over, or dv is 1 over x squared plus 1 squared.
Wait, e to the x squared, wouldn't that just be e to the 2x? It's e to the
No.
x to
No.
the x, to e to the x to the 2.
It is e to the x to the 2, but how does that make any sense?
'Cause
Oh no, it's not to the 2, because to the 2 would be multiplied, that'd be e to the 2x. This is e to the x squared, which is totally different. You can't separate them.
Chris's.
So dv is 1 over,
Looking at Liate, we're probably choosing something algebraic, right?
Yeah.
But why would I not say, don't choose everything algebraic?
It's a lot of
Because dv has to be able to be
integrated.
integrated. And if I put e to the x squared, I can't have him alone. Why not?
Because he's a u prime.
U sub. Who's my u prime? I need an x. Ooh, so if I use an x there, then who's going to be over here? Just x squared over x squared plus 1. Now, is he off by a constant? Yeah, but I can't really do
I
that.
thought we were gonna, I was supposed to pick the easier one for u.
Algebraic before we choose exponential.
Yeah, it's algebraic before.
I was gonna say, why don't we make it 1 over x squared plus 1 squared for dv? And then you have x squared. Well, I guess that doesn't work anyway.
No, we could, because then you could make u, and then we would keep an x over there too, right?
Yeah.
And then we would have u to the negative 2, but when we integrate, it'd be u to the
Okay, never mind.
negative 1, and that's going to lead to a logarithm.
Okay.
You know what I mean? So we're seeing if this works. We're going with Liate, and we're testing it out. So then, go back to v, what would that be?
1/2 e to the x.
Good. How do you double check it? I don't know why I was about to put it to you.
Derive.
Yeah. So that'd be 1/2 e to the u times 2x. 2's cancel x and remain. So that's okay, right? Du.
No.
Are we gonna either do product or quotient?
What do you want to do?
Either way, we're gonna kill us.
I can do one product rule.
Yeah, we can. But then we're gonna have nasty denominators and need to put them back together. I'm not really feeling that in junior quotient.
Cool.
So bottom v top is gonna be 2x times x squared plus 1 quantity squared minus top to bottom, which is gonna be x squared bring down the 2, so 2x squared times 2x is going to be 4x cubed, right?
It's not squared, isn't it? Oh, the top. Wait, no. Yeah.
Then you go pull out one of them and then you make it three. No, square. Not square.
You're right, I'm going to do
But
square
then we
squared
can pull
and
out a x
I
squared.
can pull out an x squared plus 1 and
And make it
cancel it,
cube.
right?
Yeah.
Then du is equal to, one of these is going to be left, that's going to be 2x cubed plus 2x. That x squared comes out, and then x squared plus 1 to the third. And then we have minus 4x cubed dx. So du is going to equal,
Pull out a 2x
that becomes a negative 2x cubed, pull out a negative 2x, right?
squared. Oh no, x
So that'd be an x squared minus 1? You can double check. Negative 2x
I'm
cubed,
just
pull out
trying
a
to keep up
negative
this.
2x
Put big ones.
dx.
Yeah, that works. Now we gotta draw our 7. It's gonna be a big 7.
Now hold on.
Dang it.
No, I'm just saying, we're evaluating, right? We're not
That's
gonna
gonna be
usually
fun
work.
when that's gonna be fun when we have to integrate that.
But they give us something
UV
this
minus
ridiculous on-
VDU. Question, is that any better?
No.
No.
But we followed the outside.
Well,
It's
the
called
auntie is a
twice
schmuck.
now. The back culture rule is not working out well.
What's the I stand for again?
Inverse string.
Inverse string. Now, what if the top had been like the U prime of the bottom? Could that have been nice, maybe?
Well, the bottom could possibly be.
Georgie, you had an idea, yeah? What was it?
I don't remember. Something about making 1 over x squared plus 1 quantity squared dv.
Too bad I wrote that down.
But that's what's gonna happen in your homework, and you're gonna get frustrated, and then you're gonna be like, wait, but there's another way. Beyonce doesn't confine us. If we did have x squared plus 1 squared in the denominator, who would we have to have up top?
X.
Alright, who would be left over here?
X squared easy x. Oh, easy 2x. But then we can't. Oh, we're just dividing one up. No, wait, easy x squared, right?
You see why we didn't do it in the first place, because it didn't seem right, right? But what's gonna happen when we go back to V?
It's
Yeah.
what's on the u wrong. So it's
Oh, thanks, I did use it.
2 times 2 is 4x e to the 2x.
you get 2x. You get 2x over x squared plus 1.
There you
Are
go.
we
4x
going v
squared.
or dv? Or du? I was
I
doing
don't know, I was doing V. So we can have U to the negative 2, right? We need a 1/2, because we're missing the U prime of 2. U to the negative 2 is gonna be U to the negative 1, right?
I'm sorry, I can't do inverse that fast.
Okay.
It's
It's U to the negative 2. U prime is 2.
No.
Well, the 2x, but then the 2's cancel, so you get x over x squared plus 1.
Second D first.
You don't need to use facts. Oh, no.
Never use the use them, if that makes sense. So second D first, that'd be U v times U prime, that'd be 2x. Plus first.
Did they give us something this crazy on the AP?
In the words of a wise man named Coach Hurst, we practice hard so the game is easy. Well, I feel like I've heard before, because Coach Hurst said it and you were Coach 7 for like half a month.
So now what do we have? You can pull out an x, you can pull out a 2x,
Well, 2x
e to the x squared. What do we have left?
x plus 1.
X squared plus 1.
No, we pull out an x. Oh, yeah. Why are you saying that?
Nobody. Okay, we're still catching up.
What reference is that?
No,
As
it's
in
just
it's gonna
No reference. It's just like a, maybe this is a good thing.
epiphany. Because the x squared plus 1 is cancelled.
That doesn't make any sense.
I think, I don't know.
No.
Yeah, Jordan, you know. let's see, x squared e to the x squared up top, and then have a 2x squared plus 1 on the bottom, minus the integral of v du. Pull out the 1/2. I have 2x e to the x squared times x squared plus 1 all over x squared plus 1 dx.
Wait, x squared plus 1 is super straight.
Don't need it. But you're right, it would have been.
Oh, I thought the.
But we don't need it because it reduces.
Oh.
It's x squared plus 1, the denominator of v, and then the numerator of du.
You have to multiply by the. By the.
Oh my goodness. Go again. Just kidding. Who's you? Who's you? Oh, okay. Integral of
We did
dv
it.
is
Yeah.
you. Go ahead and say equals x squared e to the x squared all over 2 times x squared plus 1 minus 1 over 2e to the x squared plus 2. Sure, they might have pulled out something. Who cares? At this point, we'll just say it's right.
Technically, we can just no, we can't.
What does coequals mean?
Backward version?
Yeah, cohesivos is just backward version of loisivos.
Who's better?
Horizon.
Oh.
When she went to the DR 2 years ago, didn't know much Spanish.
You know, if you say Reisner,
Hola.
Reisner to her face, just to get
Gracias.
mad at you. It's apparently it's pronounced Reisner.
Reasoner.
Yeah, I know.
Oh, interesting. I honestly didn't know that. I guess I don't really say her last name much. Never had her as a student.
Okay.
That was fun!
Loopy.
Ah! Did you guys get this one? Are we okay? Loopy! Type of integration by parts problem that goes full circle in a good way. What am I talking about? Who's you?
Me.
E!
Liate.
That doesn't simplify.
Log.
If you're thinking about just the
Cosine
definition,
trick.
u e to that 4x, that's not going to simplify when I du it, and cosine as u isn't going to simplify. Okay, maybe when I integrate e, that doesn't simplify. Integrate cosine, that doesn't simplify. They both are just going to cycle. And that's the point. Because it's going to loop around in a good way. Alright, so who are we going to choose? I don't know, you can choose the answer, you can choose the one that you like the best. Which one do you want to integrate more? E to the or cosine to the? Okay, so let's throw the e to the. And he's the last one in the Liate anyway. E to the is our dv, cosine of 2x is our u. V is equal to 1/4 e to the 4x, right? du is equal to?
2 side, negative side.
Yeah,
I think we're all just tired.
I know.
Because of Satan.
I agree.
So you can go ahead and we can say the integral of e to the 4x cosine of 2x dx. But is it sweet from the Lord? In the seventh day he was?
Yeah, and Satan's taken from us.
That's why I said we should kill him.
Because sickness is from Satan. Got it.
Yeah.
Equals uv. 1/4 e to the 4x cosine of 2x minus the integral of
Is that e to the
V
ux
to
or
u.
4?
negative.
On dv, is that e to the ux or is that a 4?
It's 4. It's supposed to be a 4.
The 1/4 comes out and joins the -2, which will make it a positive 1/2, right? Double check me, and I'll double check you. E to the 4x sine of 2x dx. Hey, it looks so much not better. But it's going to cycle if we do a similar process again. Similar meaning, if we pick trig the first time, we better pick trig the second time. If we pick trig the first time, we better pick trig the second time. If we pick the other way, it's going to go right back to the beginning and you're going to be so sad. And then you didn't get anywhere.
Well, if it's just going to cycle, why do we keep doing it?
I don't know. Let's figure it out. Sine of 2x. e to the 4x dx.
You got 2 minutes.
V is equal to 1/4 e to the 4x. du is equal to 2 cosine of 2x dx, right?
Sweet.
So this integral, e to the 4x cosine of 2x dx. And if you're wondering why I'm writing it, just wait. 1/4
Oh,
e to
I
the
know.
4x, you see it?
Yeah.
Cosine of 2x plus 1/2 times. Now it's time for 7, which will be 1/4 e to the 4x sine of 2x minus the integral. Pull out the 1/4 of the 2, which will be a 1/2 e to the 4x cosine of 2x dx. Oh my goodness, this is going to go on forever, George. What do you see?
Implicit differentiation twice. You gotta plug in dy dx. No? Like, you know what I mean? Like, when you have dy dx.
Can you know?
Oh, never mind. I take it back. I didn't see anything. You're gonna plug in the integral back into there, right?
Kind of.
Yeah. I was thinking, like, when you have dy
Kind of.
dx.
Kind of. Hold on, it's easier, I think, than how you're explaining it, though.
The equal.
They're like terms!
Oh, that's not what I was.
That wasn't true. So we can multiply into 1/2 and get 1/8, and we can multiply into 1/2 and get 1/4, and then we can do some algebra and say,
Then we add it
hey,
over.
let's combine our like terms. Who knew you'd be adding integrals one day? You learned that one. 1/4 integral of e to the 4.
What?
What? So then what do you get over here?
You say
1/2.
what now?
1 plus 1/4 is 5/4.
Oh my god, that
Integral
is
e to the
insane.
4x cosine of 2x dx
Then you can
equals.
multiply the 4/5
Who's
over.
over there? 1/4 e to the 4x cosine of 2x plus 1/8 e to the 4x sine of 2x
Let's see.
times 4/5, right?
Yeah.
On one side,
Oh, that gives rid of a lot of our.
on the other side.
No, it doesn't.
So the integral of e to the 4x cosine of 2x dx is equal to, look, we did it.
So
We
let's
said to
see
finish.
those.
Multiply to 4/5, which is going to end up being 1/5
Yeah, 1/5.
e to the 4x cosine of 2x. I'm just pull up something, but let's just not. Oh, come on, you party poopers. 1/10
He dusted us, he left us behind.
e to the 4x sine of 2x.
Let's see.
I'm wrong! George, why?
Oh, don't tell me I know.
No, you're right, you just said it.
Oh, plus C.
Why plus c?
Because we need the plus C.
Because I need the plus c, because I need my plus constant. The one struggle with the loopy, besides just being able to make the loop, is being able to say, oh, that's right, plus c at the end. Dun, 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 dun. Woo! Dun, dun.
Yeah.
When we said that we were happy with the moving circle. I don't think I'm happy with
Dude, I didn't get a stamp.
But it made it solvable!
Miss D, you dusted us.
Yay!
Dust.
Because the bell was gonna ring. George told me 2 minutes. I had to go. Hey guys, we have 2 more slides. So technically, homework is due on Friday, but technically you should be able to do almost all of it tonight. But when it says tabular method, yeah, no, peace out on that one. Just wait. Bye, see you later.
Yeah, I didn't get a stamp this morning.
Why not?
I don't know. I had my thing on my table. I just pulled it out.
You
Amanda didn't see you. She
You
was
hear
like,
that, Amanda? He just said that you failed him.
I'm sorry.
Someone failed me. I don't know if it was you or Satan. Might have been Beelzebub.
Joyce, if you like this video, like, subscribe, leave a comment in the description below.
Hi, Joyce.
Okay, now if you want to do homework.
Add us at Miss D on Twitter. Right?
sure.